Hello friends, did you ever wonder what lies behind those Diwali lights, solar cells, your TV remotes, your speakers?
Never bothered to think about these.
The basic circuit element used behind these is called a diode. A diode is essentially a two-terminal electronic component that conducts in one direction, blocking current in the opposite direction, which can be viewed as an electronic version of a check valve.
Mostly diodes are made of semiconductor materials such as silicon, germanium, selenium, etc. The most widely used diodes are the p-n junction diodes.
Can you please explain why it is called a PN junction diode?
P-N junction diode is essentially a semiconductor. Impurities are added to it to create a region on one side that contains negative charge carriers, electrons, called an N-type semiconductor, and a region on the other side that contains positive charge carriers, holes, called a P-type semiconductor.
Dope, as in?
This process of adding impurities to the semiconductors is to increase its conductivity and it is called doping.
In the N-type semiconductor, an electron-rich element, generally arsenic, antimony, is added to the semiconductor to increase the number of mobile negative charge carriers.
On the other hand, in a p-type semiconductor, an electron-deficient element like boron, gallium is added to the semiconductor to increase the number of mobile positive charge carriers.
Wait, but how does doping work in a molecular frame?
In doping, due to an extra or a missing valency in the added impurity, the impurity element makes an extra or one less bond with the neighboring silicon atoms. This way, mobile charge carriers are produced in the doped semiconductor.
At the interface of the two materials, the opposite charge carriers cancel each other and so positive charges get accumulated in the n-type region of the diode and vice versa for the p region. This region, where no mobile charge carriers are present, is called the depletion region.
But how exactly is it implemented in an electrical circuit? What do this technical term mean?
When the p-type junction of the diode is connected to the positive end of the battery, it is said to be connected in forward bias.
And if the p-type junction is connected to the negative end of the battery, it is said to be connected in reverse bias.
Wait, will you please elaborate?
Due to the charges getting accumulated in the depletion region, a potential gap is created between the ends of the depletion region that prevents the electrons of the n-type junction from crossing over the depletion region and moving towards the p-type junction.
So when the diode is connected in forward bias, the electric field generated inside the diode enhances the mobility of the charge carriers. This is because the direction of the electric field facilitates the electrons to cross over the built-in voltage. So in forward bias, no current flows till the voltage of the external source is greater than the built-in voltage of the depletion region.
Now for reverse bias. The direction of the electric field is such that it further prevents the electrons to cross the depletion region. This inhibits the charge carriers to traverse through the depletion region.
In spite of this, due to the kinetic energy possessed by the atoms, due to the temperature, the electrons move to the p-type junction in very small amounts and produce a low current called the reverse saturation current.
Hopefully now you know much more about diodes than you knew when you started.